So we've solved equations that have the different roots in there, but we haven't done anything with the rational exponents yet. So we're going to look at some examples where we have rational exponents in our equation. So the first one, let's look at negative 2 times x to the 3/4 equals negative 16. So just a reminder what that 3/4 power means. That means that we're raising x to the third, and then we're taking the fourth root of that. Okay, so just keep in mind when we get down to dealing with that. But the first thing we would want to do here is get rid of that times negative 2. So divide both sides by negative 2. Remember, we're just undoing everything that gets done to that x. So then we have x to the 3/4 equals a positive 8. Now I'll just show you what the easiest way, I think, is to deal with these, and then we'll talk about why that works. We need to get rid of that 3/4 power. Right? We have x to the 3/4. We want to get rid of that. So we're going to raise both sides to the 4/3. And there's a couple reasons that this works. One, if you just think about when we raise a power to a power, what do we do with those? When we have a power to a power, we multiply them. And if we multiply 3/4 by 4/3, the 4's would cancel out, the 3's would cancel out, and we would just have x to the first, right? Which is just the same as x. So by raising to that reciprocal power, we've dealt with that 3/4. Another way you can think about it is, again, x to the 3/4 means that we're raising to the third power, taking a fourth root, right? Well, if we're raising to the third power, the opposite, or the inverse of that, would be taking a cube root. So we want to do something to a third power. Or if we have x to the 3/4, that means we're taking a fourth root. So to undo that, we would raise to the fourth power. So we can do both of those steps at the same time. Kill two birds with one stone. Okay. So then we just have to remember how we evaluate something like 8 to the 4/3. Again, the easier thing to do first is the root. So the cube root of 8 is 2, right? So the cube root of 8 is 2, and then we just have 2 to the 4th. That's 2 times 2 times 2 times 2, which gives us 16. So x equals 16. In this next example, we have 1/2 x to the 5/2 equals 16. So to get rid of 1/2 times that x, we could either divide by 1/2 or multiply by 2. Right? Multiply by 2. So we have x to the 5/2 equals 32. To undo that 5/2 power, we're going to raise both sides to the 2/5. Because again, 5/2 times that 2/5 is going to give us x to the first. So then we just have to evaluate 32 to the 2/5. Fifth root of 32 is 2. So then we just have 2 to that second power, which is 4. One last example. Maybe a little bit more complicated, but again, we're just undoing everything that we see. Okay, so we have x plus 2 to the 3/4 minus 1 equals 7. Don't do anything with that power yet. We want to get that by itself first. So we get rid of that minus 1. So we add 1 to each side. So x plus 2 to the 3/4 is equal to 8. To undo that 3/4 power, raise both sides to the 4/3. So those cancel out on the left, and on the left side we're just going to have x plus 2. 8 to the 4/3, so deal with that cube root first. Cube root of 8, again, is 2. To the 4th is 16. I think we just did that in one of the previous examples. So x plus 2 equals 16, minus 2 from both sides, and x equals 14.